So here's section 7.2, and these are really similar to the ones that you've already done in section 7.1. And the only real difference in these is that they give you a mean and a standard deviation that you have to put into the calculator rather than keeping those numbers as 0 and 1. So this first one says cherry trees in a certain orchard have heights that are normally distributed with a mean of 114 inches and a standard deviation of 13 inches. It says to use the table, but you can use the calculator for all of them. So at least at this point, don't worry about using table A2 for any of these. What proportion of the trees are more than 123 inches tall? This you'll work the same way as we did in 7.1 when it said area to the right. If it says more than, that's 123 or bigger numbers. So picture it on a number line. It would be numbers that start at 123 and go to the right. And in the wording now, when it says more than, you don't have to say, you don't have to change this number. You'll be using the exact number that they give you. You don't have to worry about the more than 123 versus 123 or more like you did in the binomial thing. You'll just always enter the number that is given to you in the problem, which is a very nice thing. Okay, so second, vars normal CDF is where we're going to go for these, just like in 7.1. And now we want trees that are somewhere between 123 inches, and there's no upper limit on how tall the trees are that we care about. So we're going to use that E99 as our upper limit. So literally we're saying trees between 123 inches and some crazy huge number one with 99 zeros after it. So now mean is given to us, just plug it in, 114, standard deviation 13, and that's our answer. So that's all we have to do for this type of problem. So this is a more than, the less than and between ones are very similar, so we'll go through those real quick. Second vars, normal CDF. Now we want less than 105 inches tall, so the lower limit, a lower limit of negative infinity in this case doesn't actually make sense, but you can still put that in. And if 0 makes more sense to you, you can actually put that in too, and you'll end up with the same answer conveniently. So negative 1E99, so somehow that is a tree that is negative infinity inches tall, and up to 105. Mean and standard deviations stay the same, and we get 0.244. Oh, if it tells you to use the table, it might not tell you how many decimal places to go out to, so go out to 4 in that case. And I'm just going to try this one with putting 0 in there for the minimum height to make sure that we get the same answer. Second vars, normal CDF, lower limit of 0, upper limit of 105, everything else stays the same and exactly the same. So it doesn't matter if our lower limit in this case for something that can't be, like if it's a height of a tree, it really can't be negative, and 0 makes more sense to you, totally fine. Probability that a randomly chosen tree is between 88 and 98 inches tall, and that is my favorite situation because it's the most straightforward, because now the lower limit is the first number they give you, upper limit is the second number they give you, Mean and standard deviations stay the same, and that's your answer. So these are all pretty straightforward in terms of how you get the answer, and all the other problems that are like it are going to have different words, different means and standard deviations, but mostly they'll just be asking you a more than, a less than, and a between answer.